Hello dear learners, today we will discuss about introduction to carbon nanotubes. It is yet another topic in the field of physics which is growing very rapidly. In this topic, these are following learning outcomes that can be achieved after discussing. The first, the learner will be able to understand what is carbon nanotube. Then second, the learner will be able to identify the types of carbon nanotubes. Third, the learner will be able to understand properties of carbon nanotube. And fourth, the learner will be able to understand some applications of carbon nanotubes. Now, let us begin with our topic. What are carbon nanotubes? As you can see, carbon nanotube is a hollow rod which is been covered from both the sides by a cap-like structure. It is arrangement of carbon particles in such a way that they form a long fine rod having very small diameter. Let's discuss what it is. It is the allotropic form of a carbon. Now we know that carbon is found in the nature in many allotropic forms, starting from graphite, then diamond and coal, and it is yet another allotropic form of a carbon where the arrangement of atoms and molecules is slightly different. As you can see, carbon nanotubes are having cylindrical shape. Its shape looks like a cylinder made up of carbon atoms. Now, what about the radius? The radius of carbon nanotubes is very small. In fact, it is measured of few nanometers compared to its length. As you can see, carbon nanotubes can grow up to 20 centimeters in length. You can imagine that the diameter is in the range of few nanometers and its length is about few centimeters. Now, this is drastic change from its previous allotropic forms. Again, as you can see that carbon atoms are having hexagonal lattice which are forming the walls of the tube. Here you can see these carbon atoms are placed in such a way that they are forming the hexagonal lattice, and here again you will find at the front end and the back end it is having a cap like structure. This is known as fullerene like molecule. Fullerene is the first carbon form which is found in the range of few nanometers. Okay, this is all about introduction to the carbon nanotubes. What are carbon nanotubes? Let us discuss in what are the types of carbon nanotubes. As we know that carbon atoms, when they are hexagonally arranged with each other and form a single sheet, then we can have carbon nanotubes. See, look in this diagram, you will find that this is a sheet of carbon molecules having hexagonal structure, and if we roll up this sheet, this is known as graphene sheet. If we roll up this two-dimensional graphene sheet, then we form a one-dimensional carbon nanotube. These all three are nothing but carbon nanotubes, and this is known as single-walled carbon nanotubes, famously known as CNT. But can we have multi-walled carbon nanotubes? Yes, of course we have multi-walled carbon nanotubes. If such carbon nanotubes are stacked with each other, then we form a multi-walled carbon nanotubes. You can clearly see in this diagram that there is a multi-walled carbon nanotubes having different diameters obviously. So, these are the types of carbon nanotubes, and it is in a pristine form. Pristine form, it means it is in the purest form. There is no contamination, anything when in carbon nanotubes. Now, let's move to the reflection spot. What we are expecting? Let us raise a question. What if a suitable impurity of having few nanometer size is added to the pristine carbon nanotubes? Let's think over it and I will answer. The answer is, it is known as composite of carbon nanotubes. I will give a single example. Let's have cadmium sulfide, CDS nanoparticles, and when they are attached with the carbon nanotubes, it is found that the photocatalytic activity is bettered in comparison with pure CDS nanoparticles. I have provided the reference for the same. Hence, we can say that by addition of some impurity, some suitable impurity, properties can be enhanced. Now, let us discuss what are those properties. The first, carbon nanotubes have very high thermal and electrical conductivity. It is contrary to the previous allotropic forms of carbon. When carbon is in the form of coal, in the form of diamond and graphite, it is a bad conductor of heat and electricity. But the carbon nanotubes are good conductor of heat and electricity. Similarly, carbon nanotubes are very good dopants. We can add some impurity to it and enhance the properties. They have very high aspect ratio. Aspect ratio is nothing but the diameter of a molecule, diameter of a carbon nanotube to its length, and as we can see, its diameter is very small and its length is very high. Thus, carbon nanotubes do provide very good morphological control compared with its contemporary materials. Again, carbon nanotubes are highly flexible. Its flexibility is much better than other materials with having very high tensile strength. Let's go to the applications of carbon nanotubes. Now we have discussed its properties, we know what are carbon nanotubes, and let us discuss what are the possible applications of carbon nanotube. Carbon nanotubes are used in energy storage, in terms of supercapacitors and batteries. Carbon nanotubes are quite offensively used in molecular electronics so that electronic structure can be enhanced. They are also used as a thermal material. As we know, they are having good thermal conductivity. They are also used to modify the structure of a material. They are having good electrical conductivity. That's why they are blended to increase the electrical conductivity of the material. And again, it is one of the best use of carbon nanotubes. They are used in materialing, in forming fabrics and fibers, which are known as super fibers. In biomedical, carbon nanotubes are producing excellent help to the doctors and scientists. Drug delivery system can be modified using carbon nanotubes, and it is also used in water and air filtration process, which is the demand of today's world. This is all about carbon nanotubes. I hope you have enjoyed my lecture. Thank you very much.